This episode is brought to you by EnergySage, the nation's most trusted online solar marketplace. Head to EnergySage.com to start exploring rooftop and community solar options in your area. Also, this episode was filmed on January 12th, 2021. If we have any updates on this topic or related to the COVID-19 pandemic in general, those episodes will be in the playlist linked in the description. By this point, you've probably heard about the UK and South African variants, two new versions of the coronavirus that causes COVID-19 that were announced in December. They're already spreading quickly in their countries of origin, as well as hopping around to other parts of the world. And what we know about them so far is pretty concerning, but there is also good news here, like that the vaccines that we have should still work. So let's talk about it. Now, all viruses mutate, meaning they acquire changes in their genome as they make copies of themselves. So these definitely aren't the only variants of SARS-CoV-2, the COVID-19 virus, that have arisen in the past year. But what's important to know is that mutations usually don't change the virus's machinery much, if at all, so they don't tend to alter how it spreads or how it sickens its host. Not even mutations to the infamous spike protein, the part that sticks out of the surface of the virus particle and essentially unlocks the host cell. In fact, scientists have already spotted over 4,000 versions of it. Of course, sometimes mutations matter, which is why researchers were keeping an eye on genomic changes to SARS-CoV-2 when a steep rise in cases in Southeast England in early December warranted a closer look. And it turned out that most of those cases involved a new variant, now known as B117. And experts think that's because B117 behaves a bit differently than the original virus. And a similar variant was identified in a spike of cases in South Africa around the same time, which virologists have dubbed B1351. What stands out about these two is that they appear to have accumulated a large number of mutations pretty suddenly. For instance, B117 is defined by 17 important mutations that seem to have happened all at once. And the most likely explanation is that the virus was able to mutate multiple times in the same person because of a really prolonged infection, which researchers have seen before on a smaller scale. Regardless, the good news is that these variants don't seem to be making people any sicker. So as far as we know, you're not more likely to have a severe case or die from them. However, they do seem to be making people more contagious. Early statistical models of transmission are kind of all over the place, but they suggest the variants could be between 10 and 70% more transmissible, meaning a person infected with them is that much more likely to spread it. And unfortunately, that's worse than a similar increase in deadliness. And that's because increases in transmissibility lead to exponential increases in cases. Like, let's say that a person with COVID-19 infects two other people, and 2% of people who catch the virus die. The first person passes it on to two others, who pass it on to two more, and so on. So after 10 rounds of transmission, you end up with about 2,050 people infected and 41 dead. A 50% increase in deadliness would mean that 62 people die instead. But a 50% increase in transmissibility means over 88,000 get infected in the same amount of time. So 1,772 people die, even though the virus isn't more likely to kill. Now, assuming the transmissibility data hold, the big question is why these variants jump between people so easily. One thing that's been noted is that people who have them seem to have more viruses in their bodies, or a higher viral load. Preliminary estimates vary, but overall, people with these variants seem to have several times the number of viruses in their respiratory samples as people with the old versions. That may mean people with them put out more potential contagions in their respiratory droplets, making it so that people who come into contact with those droplets are more likely to become infected. It's not entirely clear yet, though, if this is what makes the variants more transmissible. Higher viral loads could be explained by a virus that replicates more quickly, infects cells more efficiently, or makes people sick faster or for longer, all of which could also lead to increased transmissibility. Whatever the explanation, higher viral loads tracks with growing evidence that these variants are simply better at being viruses. We don't know yet exactly why, but their genomes provide clues. For instance, B117 has mutations to genes that are thought to play important roles in keeping cells from realizing they're infected. Both variants also have mutations to the gene that codes for the spike protein. Like, both have a particular one that changes the shape of the region that makes direct contact with ACE2, a protein on our cells which is usually the virus's ticket in. This mutation could make those spikes stick better and help the virus break into cells more efficiently. In fact, this is one hypothesis for why more children seem to be catching these new variants. While they have fewer cells with ACE2, that might not matter to a virus that is better at sticking to cells when it encounters them. But there are other factors at play too, like that schools remained open during the lockdowns in the fall, so there are still a lot of questions. Speaking Speaking of, scientists are keen to figure out whether the vaccines that we have will be effective against these new variants, and whether they're more likely to cause reinfections. That's because the spike protein is usually the part that our bodies learn to spot after an infection, and what most of the COVID-19 vaccines teach our bodies to target. So mutations there could throw a wrench in things. But so far, experts don't think that'll be the case, especially with B117. They're somewhat more concerned about B1351, the South African variant, because it has a couple of additional mutations, but they're also careful not to jump to any conclusions. They're urging caution and research, not panic. Really, if there's one thing we're sure of, it's that we need to continue following the health advice we've been given for months. So while the scientists do their thing, we all need to wear face protection, wash our hands, physically and socially distance from others as much as possible, get a vaccine when we can, and follow all of our local health mandates. There can be a bit of a research scramble that happens when a new potentially dangerous variant shows up, which is why you're seeing a lot of headlines about these. But while concern is warranted, the experts are on it. Thank you for watching this episode of SciShow News. Before I go, I have a brief message from today's sponsor, EnergySage. EnergySage is the nation's most trusted online solar marketplace, so they can help you turn your dream of a solar-powered home into a reality. They've pre-screened solar installers all over the US, so when you register on their rooftop solar marketplace, you'll receive quotes from local installers you can trust. And if you have any questions, their expert team of unbiased energy advisors can help. If you're interested, head to energysage.com to see how much you can save by going solar.